and they have colored liquids in them. How do we know they're liquids? We just shake them up a little bit. We know from experience what liquids do when they're shaken. So if I take the card away, can you see the colors? Still see the colors?
Yes.
But can you see them better with the card in this location, or if I take it away?
If it's there.
You can see them better this way. So these are different chemicals, and they are colorful. We receive color information through our eyes, and very fascinating chemical changes happen in the brain as the brain gets the information through the eyes. So let's see if we all recognize that this is the visible region of the electromagnetic spectrum. And this is where the human eye is sensitive to the energy. And as you can see in this chart, there are different colors. What's at the bottom? What's at the top? Oh, and what else does it say on the top? So this tells us something about the relationships between the colors and the amount of energy that they have, right? So, which is more energetic, red or green?
Green.
Which is more energetic, green or purple?
Purple.
All right, on the back of this card, what do you see I have on the back of this card?
Yellow. Yellow.
I'm going to show you what I have on the back of this card by using two devices that I have right here. I'll put one in my pocket, and then I'll use this one. Can you see what this one is?
Laser.
You see it over there?
Yeah.
Can you see it over there? Right, right? All right. Now, what do you think is going to happen when I shine this green laser on the back here? Can you see it now? Can everybody see it? All right. All right. Now I'm going to switch. I'm going to switch the two that I have here. Where's the other one? There's the other one. Now, what color is this one? Can you see that one? Can you see that one now?
Oh, I have that. I have that.
What happened?
Ultraviolet.
That's what we want to know. What happened? So this is a sheet of paper that is sensitive to light. And what I want to show you here, if I can. Okay, now can you see the color of the laser that I have here? What color is it? Blue. What color was the other one? Which one has more energy? The green one or the blue one? You forgot?
Blue.
That's why we have the chart. Right? All right? And that's why we can see what I'm going to write here. Can you turn the lights out down? See what's, can you still see it? Yeah? Yeah? And we can just do this all over the place and have a jolly good time and so on. All right? But if I try to do it, with a green laser, then I will not be able to see it. Here's my green laser. See it right up there, right there? That's kind of interesting too, right? But if I try to do it here, nothing of the same sort happens. So, with the lights up, please. So the eye is sensitive in this region of the electromagnetic spectrum. And color changes give us an indication that some chemical reactions have occurred. And that's why I want to go back to where I was before, to the cylinders that have the colored liquids. And what I'm going to do is pick up my gloves, put my gloves on. In fact, I want to ask you to do the very same thing I asked my students at the University of Wisconsin to do. In order to sharpen your powers of observation and develop better skills of reporting the observations, I would like you to pretend to be the play-by-play radio announcer, describing to someone who's not with us what's actually going on. Not the TV announcer. That picture tells almost everything. So pretend that you're on your cell phone or on the radio telling someone who's listening what's actually going on. So I'll help out a little bit. How many cylinders do we have? And what's in the cylinders?
Liquid.
And are the cylinders arranged in some kind of order or just haphazardly?
Order.
They seem to be arranged in pairs according to the colors of the liquids in the cylinder. So what I'm going to do now is reach behind here, open this up, and I'm going to pick up a white solid, chunks of this white solid. This is called dry ice. Dry ice is solid carbon dioxide. It changes from being a solid to a gas directly by a process we call sublimation. Can you say sublimation?
Sublimation.
Sublimation is happening right now, but we can't see it. So it doesn't melt. It changes directly from a solid to a gas without melting. We can't see it because carbon dioxide gas is mixing with air, which is a mixture of gases. That's why we can't see it. But if I take a few chunks of the dry ice, one just dropped on the floor, and I put one here, and one here. Now do you see anything happening? What's happening?
Whoa.
You're talking on a cell phone to somebody else and telling them what's going on. Don't raise your hand, just say it. Just
The
talk.
colors are changing because the gases, they have a chemical reaction.
You know what? I love this sound I just heard. Mumble, mumble, mumble. You know why I love it? Because everyone is reporting their observations the way they want to report them. We all have the freedom to report our observations the way we want. I could ask you a question and get the same answer out of you. How many cylinders are there in this experiment?
6.
Okay, so, all right. How many cylinders altogether on the tabletop? More than 6, okay. How many more than 6?
12.
Do I have to ask all the questions all the time, right? You're asking all these questions. Well, I'm trying to get you to focus your attention and pay attention to what's going on. So, in this pair, where I put the dry ice in the cylinder that changed color, the color change was from blue to what?
Yellow.
How about in the middle pair here? It was from pink to what? This is a clear and colored liquid. This is a clear and colored liquid. This is clear and
Transparent.
colorless. From now on, no one in the audience is going to confuse the words clear and colorless. They don't mean the same thing, right? So we have to be careful in reporting our observations. All right, so what I'm going to do next is get some more dry ice. There it is. And I'm going to ask you to focus your attention on this cylinder right here. You can look any place you want, but if you want to follow my experiment, pay attention right on this cylinder here. As I take the dry ice and drop them in there, and tell me how many different color changes you see out loud.
1, 2, 2.
Are we expecting one more to happen? It hasn't happened yet, so we have to be patient, and we have to be always paying attention to what's going on, so we try to make some sense out of it. You see something coming off the top here? It looks like smoke, but it's not smoke. What it is, it's condensed water vapor. It's a mist. It's the same as the stuff that floats up in the sky we call clouds. It's actually a fog that's being formed here. And I want you to notice that the fog is moving downward, telling us that carbon dioxide gas is denser or heavier than air. Now I also want you to look right over here at this big conical flask that has a side arm. It's open right here. If I open it like this, do you see anything coming off the top? Anything coming from the side? What do you see? This is water boiling. Steam is invisible. You can't see steam. What you see is condensed water vapor. So the condensation is taking place, and in this case, the condensation is taking place in the carbon dioxide gas, and it's floating downward. In this case, it is floating up because there's no carbon dioxide in here at all. So I'm going to take this dishpan, which is empty except for air. I'm going to use my gloves to protect my hands from the heat now. And I'm going to put the water in there. What do you see coming off the top? Condensed water vapor. That's what you see, condensed water vapor. I put this back on like this. Then I'm going to take some more of the dry ice that I have. The temperature of the dry ice is minus 78 degrees Celsius. It's very, very cold. And I'm going to put the dry ice here. Right there it is. This is how they make fog in the movies sometimes. They take boiling water, put dry ice, and put a fan on it, and blow it. You notice it's moving downward, again telling us that carbon dioxide gas is denser or heavier than air. All right, so we've seen some color changes so far. Let's do another experiment. This experiment I want to do with these two flasks. I'm going to hold these flasks, and you can see that they have in them about the same amount of a clear and colorless liquid. I'm going to take the one in my left hand, and I'm going to shake it. You see a color change? I'm going to take the one in my right hand and just give it a little shake. You see a different color change. So these color changes, let's see if I can shake them both real hard. And we set this down and watch to see if there's any more change in color as reactions take place. So in this set of experiments over here, we had dyes that change color as the pH, as we call it, of the liquid changes. So the amount of acid or the amount of base that's in there affects the color change. So let me take a look here, see what's going on. So we had one set of dye in here, another set here, a third. This one was actually a mixture of dyes. These dyes, when they change color, they indicate to us that a chemical reaction has taken place, and that's why they're called indicators. In this case, they're called acid-base indicators. For those of you in the audience who want to know what the indicators are, because I get questions about them all the time. In this pair I had bromethymol blue, this is phenolphthalein, and this is universal indicator, which is a mixture of 3 or 4 different indicators. So these color changes tell us that a reaction has taken place. Now I'm going to do an experiment using the liquid in this bottle. How would you describe the liquid in this bottle?
Colorless.
It's clear and colorless. How about this one?
Green.
Clear and blue. So what I'm going to do is open both bottles. I have in front of me a flask and a funnel on top. And what I'm going to do is mix those two liquids in the dark. So if we can turn the lights down, please. And mix them in the dark, and we get a nice blue color change. This is the release of energy in the form of light. With the lights up, please. So this reaction releases energy. We can tell that it has taken place because we saw the color, and I can tell you it's at room temperature. It did not get hot. This is called chemiluminescence. Can you say chemiluminescence?
Chemiluminescence.
Chemiluminescence is when energy is released in the form of light, but not in the form of heat. Here's an example where we have the release of energy. Maybe. Maybe. Maybe not. So here's an example of a reaction that releases energy in the form of light, but also in the form of heat. In fact, I can tell you if I put my hand close by here, it is hot. And you know this from experience. This reaction releases energy only in the form of light. It's called chemiluminescence. And I should blow this out before I burn myself, right? So be careful about handling all kinds of chemicals You notice that the color has changed? And let's turn the lights down to see if it's still glowing in the dark. Not much, not much, it's not glowing at all. Oh, well, just faintly that I can see it here. All right, we come back here with the lights up. How about our two flasks over here? You see the colors have faded. So color changes tell us that chemical reactions have taken place. So what is going on over here? In this one here, I shake like this. This has in it a little bit of potassium hydroxide, lye. It has in it a little bit of dextrose, which is a sugar. And it has its own indicator, which is different from this one. But everything else is the same. And what's above the liquid, you notice that the flasks are stoppered. What's above the liquids is air. Air is a mixture of nitrogen and oxygen, about 20% oxygen and 80% nitrogen. And it's the oxygen in the air that's reacting that gives us the color changes. And the reactions are taking place where the oxygen combines with the dextrose, and the indicators catalyze the reaction. So we can watch those a little bit and see what else happens. So let me go to this end over here now and do an experiment. This experiment I'm going to do in this flask. Can you see the color of the liquid in the flask here? What color is it?
Blue.
Can you see it's colored? Yes? Yes? All right. You can't see it's colored? I'll come over here and show it to you.
Blue.
Now you can see it's colored, right? Right? What? Yeah, right. Can you see it's colored? All right. So what I'm going to do now is carry out an experiment using the element sulfur. Sulfur is a solid at room temperature. I'm going to take some sulfur and I'm going to burn the sulfur using the torch that I have over here. Okay, so that's what this is for. And so I'm going to take this off. I'm going to scoop some sulfur. Can you see the color of sulfur now? Yeah, it's yellow, right? Now I'm going to burn it. Can you see it's caught on fire? Kind of? I want the sulfur to melt. And now I'm going to stick it back in here. You see this beautiful blue glow? You know why we see it better in the flask than we did outside? Because I had more oxygen in there. I filled it up with oxygen. So it was more than 20% oxygen. So that's a very nice glow. And you also notice it's hot, so I need my gloves. I had my gloves right here someplace. And even though I'm going to pick up the flask with one hand, I better have my other hand ready and protected, right? We always follow the safety rules. And now I want you to tell me what color you see in the liquid at the bottom. So, when we burn sulfur, we get sulfur dioxide, which is a pollutant. It's a very sulfurous material. You know, when volcanoes erupt, they give off sulfur also, and it's sulfur. And then, so what I had down here is the very same indicator at the very far end there, bromethymol blue, and the solution became acidic. So sulfur dioxide with water gives us acid rain. And maybe you can smell a little bit of the sulfur here. That's why we're doing the experiment right next to this very powerful suction. So we don't want the sulfur dioxide to be in the room. Now, when I do these science experiments, I always like to include other people who have their own talents. And that's why I would like you at this time to welcome a group of students, my new friends from the New England Conservatory of Music, Julian Posnick, who is from Madison, and his friends, who are going to sing a song related to the experiment that I just did. So Julian, you want to use this? Yeah.
All right, is this on?
Yeah, it's on.
All right. So, at the end of the 1500s, Europe was experiencing this golden age of exploration and discovery. They were sending out these wonderful explorers to go and bring back stories and fantastical things that they had never experienced before. They brought back things to Europe like cochineal, which is this insect from Mexico that creates a bright red color. We've been talking about color. They also brought back fine china from the Far East, but they also brought stories of fish that would fly because they had very, very long fins that looked like wings. And they also brought back stories of these huge volcanoes that they would find. In 1598, the island of Iceland, which was then called Thule, the volcano of Hekla exploded and just belched ash and sulfur into the atmosphere, and it captivated explorers who saw it. They brought back these fantastic stories to Europe, and a year and a half later, a young composer named Thomas Weelkes, who is a personal friend of William Shakespeare, decided he was going to write a song about the new fantastic things that were being brought back from abroad. So I'm going to read the text that he decided to set for this song, which talks about all of these fantastical different things. And when we're singing, try to listen for what we're singing about, because he talks in the text about sulfuric fire and all of these fantastical things. Thule, the period of cosmography, doth vaunt of Hekla, whose sulphurious fire doth melt the frozen clime and thaw the sky. Tanacrian Etna's flames ascend not higher. These things seem wondrous, yet more wondrous I, whose heart with fear doth freeze, with love doth fry. The Andalusian merchant that returns, laden with cochineal and china dishes, reports in Spain how strangely Fogo burns, amidst an ocean full of flying fishes. These things seem wondrous, yet more wondrous I, whose heart with fear doth freeze, with love doth fry.
Cosmography of cosmography of cosmography of with fear doth free, with love as love doth thrive, with love doth thrive. The Andalusian merchant that returns with Portuguese and China dishes, with Portuguese and China dishes, Portuguese and China dishes, Portuguese and China dishes, reports in Spain, reports in Spain are strange.
You've been rehearsing other songs too, right?
We have indeed.
Is there one that relates to some famous scientist?
There is one that we have if you'd like to hear it.
Not me though, right? It's not me, right? It's not about me, right?
Of course not.
Oh, okay.
Would you like to hear one more?
Sure.
Yeah.
Yes.
So, around the same time period, is this still on? You can hear me?
Yeah.
All right, around the same time period, or slightly afterward, there was a very famous scientist in a different discipline who completely changed the world of science, and that man was named Galileo. How many of you have heard of Galileo? Okay, I think we all know who he is. Well, not many people know that, in fact, his father was a very famous musician of the time, Vincenzo Galilei, who was a great lutenist who played the lute, which was like a guitar, and a music theorist who wrote many, many texts and treatises about how music theory and the organization of pitches mirrored the organization of celestial bodies, and the way that Jupiter and Mars and Venus traversed the sky was very similar to the way that pitches revolved around each other in music. Well, Vincenzo Galilei in the 1560s met another famous composer named Orlando de Lassus, and the two of them began doing sort of experiments of their own with music, and they were trying to find new musical colors that they could try and use in their compositions. So they wrote and performed short pieces for each other, and sort of had a little musical laboratory where they would try things out and see what worked and explore these colors that we've been talking about today.